In today's class, we will continue the discussion that we were having, but I will try to go through these problems very quickly. So what you have is you have this hole. There is a hinge here. And then you have two forces. These two forces are at an angle. So what we need to do is we need to resolve this force in the horizontal direction. We need to resolve this force in the vertical direction. So this is going to be Px and this is going to be Py. And this is going to be Fx and this is going to be Fy. So Px and Py, Px is at the lever arm of 12 plus 6, which is 18. If you look at the coordinate system is x, y, z. And summation of moment about O, is Px multiplied by 12 multiplied by 18. Curl your fingers in the direction of moment. Is it positive or negative? Positive or negative? Positive. Curl your fingers in the direction of moment given by Fx times 12. Do you agree with me? And then what you need to do is you need to substitute the values. Since this angle is 45 degrees, this angle is 45 degrees. And some of you can tell me what is this angle quickly. I think this angle would be tan inverse of 3 by 4, which is 36 degrees. So it's going to be P is 50 cosine 45 times 18 minus 80 cosine 36 times 12. You can calculate, and if it has a positive sign, the moment is positive. If the resultant has a negative sign, moment is negative. Now this question is again similar. You have the force and you need to find out the moment given by this force. Now the way to solve this problem is, what you need to do is you have this 80 Newton. You need to resolve 80 Newton perpendicular and you need to resolve 80 Newton parallel. Now please understand, angle theta is given with respect to 80 Newton. So this angle is actually 90 minus theta. So I would say, so basically what you do is, this is going to be sine of theta and this is going to be cosine of theta. And what you need to do is you need to set up the moment equation about A. So you have to find out the moment equation about O. So what you do is you have to find out the moment about O. So if your theta value is 60 degrees, then your moment, summation of moment about O, x, y, and z. Curl your fingers in the direction of moment. It's going to be F sine theta multiplied by 400. And you can see this moment is negative. Do you agree with me? Now, next question is something very interesting. Next question he is asking, find out at what value of theta. Find out at what value of theta. So what would be the value of theta when moment is maximum? Tell me without solving the problem. Tell me what should be the value of theta in the moment. The moment will be maximum at that angle is maximum. Because right now the force is at an angle, as soon as that force becomes perpendicular, the entire force of 18 Newton becomes perpendicular. It's gonna give you the maximum force at the lever arm, and that's gonna give you the maximum moment. Everyone understood this? How do I represent this mathematically? That is one. How do you find out? So here is the equation. The equation here is moment, and I want you to remember this. This is an important equation. Moment is equal to minus f sine theta multiplied by 400. Where please note f is a number, so which is minus 80 times 400 sine theta is equal to moment. How do we find out maxima or minima? How do we find out maxima or minima? The derivative. No. What it means, I'll give you another more intuitive explanation. At the end of the day, derivative is the slope of the line. Do you agree with me? At the end of the day, derivative is the slope of the line. Derivative is given as dy divided by dx. Basically, what is dy by dx? From your high school algebra or geometry, you have studied the slope is given by rise by the span. So this is delta y divided by delta x, or also called as rise divided by run. You agree with me? Now what I want you to do is, I want you to look at that curve. That curve has some expression. It could be a sine expression. This would be a sine curve. It could be a cosine curve, or it could be any curve. Now what I want you to do is, I want you to track the slope of this curve. Do you agree with me? Slope here is this. Slope here is this. Slope here is this. As soon as it goes to an extreme point, you agree with me, my slope becomes 0. You agree with me? Now let's look at it. Then go back, go down here, go down here, go down here. Can you see here the slope also becomes 0? Which means if you have an equation and if you want to find out extrema value, it could be maxima, it could be minima. What we do is we find the slope or the derivative of this equation and equate it to 0. Do you agree with me? We find the derivative of that expression and equate it to 0. To find out whether that extrema is the maximum point or the minimum point, we find the second derivative. And I want you to think about it very carefully. What is second derivative? Second derivative is nothing but slope of slope. You agree with me? Second derivative is like slope of slope. Now, I want you to think about it. Once again, the argument is this is a curve. It could be sine, it could be cosine, it can be anything. I want to find out whether it's an extremum position, either at top, bottom, wherever. Look at the slope. Whenever the slope is zero, it means the rise is zero. Whatever the run is, rise is zero. Then the curve is not rising. That is the point of extremum. Do you agree with me? Now, so to find out extrema, I would take the derivative and equate it to zero. I take the derivative and equate it to zero. Now, whether that extrema is maxima or minima depends upon the slope of the slope at that point. Once again, I repeat. And unfortunately, this is an engineering perspective of mathematics. So you saw, you will find the derivative, equate it to zero. Whatever answer you get, this is the maximum. But if you want to find out whether it's a minima or maxima, you find the slope of the slope, it means d2x by dy square, and then find its value at that location, and that should tell you whether that is maxima or minima. So in this case, I would do dm dx minus 3200. What is the derivative of sine? Cosine theta, and this needs to be equated to zero. So cosine theta is equal to 0. So theta is equal to 90 degrees. Do you agree with me? Okay. This problem is in principle similar to the problem that I have solved. So this problem I'm going to assign you as the homework. 315 as a homework. 316, again, it is similar, the same problem. So I'm going to assign this as homework. Now, in this problem, now please try to understand, we are trying to find out the moment that is given the hammer is subjected to the force of 20 pounds. Determine the moment about point A. Hammer is subjected to the force of 20 pounds. Determine the moment of this force about point A. To solve this problem, what we need to do is, we need to resolve this force in the horizontal direction, which is F cosine 30, and we need to resolve the force in the vertical direction, F sine 30. Do you agree with me? Now, I want you to look at this figure carefully, but it's not clear. Okay, I want you to look at this figure very, very carefully. And I want you to tell me what is the lever arm for F sine 30. Can you see the lever arm for F sine 30 is 5. Do you agree with me? What is the lever arm for F cosine 30? Can you see the lever arm for F cosine 30 is 18. And then you set up the problem. So, and recognize your coordinate system. You can have the coordinate system about A. X, Y, Z. And then you should be able to find out the answer. Can somebody tell me what is the answer? F cosine 30 multiplied by positive or negative? Curl your fingers, curl your fingers. Negative. Then F sine 30. Curl your fingers. What? F sine 30 is moment about this guy, right? It is like this. Who says positive? Yeah, you have to curl your fingers. That to right hand fingers. Everyone understood this? Why now? You should be expert. Okay. Now this is the problem. Now what you have is you have a pulley and you have a rope. For the pulley drive, you have tension with the rope. Understand? Rope cannot be compressed. Rope can only be pulled, or rope can only be subjected to tension, not compression. Do you agree with me? So now you have one force on the top and one force in the bottom. Now what you need to do is you need to find out their respective lever arms and find out the moment about point A. You have to find out moment about point A. And I'm going to give this problem as homework. Yeah. So 319 is a homework. So again, this is also a similar problem. What you have is you have mg stands for megagram, 1000 kilos. So 10 to the power 6, so 10 to the power 3 kilos is mega. So basically, what you have is you have 2 megagrams, which is 2000 kilograms. And this is 1500 kilograms. This is 500 kilograms. And as you know, that these forces are acting at different locations. So for an example, 1.5, 2 milli, this load is hoisting. So here, the force is 2000 kilogram. Then you have BD, this BD, and then you have 1.6 megagram. So, and again, I want you to remember there is a concept which is called as the centroid. Centroid means what? Imagine this is an object, this is a beam. Its mass or the weight is distributed. Its mass or the weight is distributed. But if I want to balance it, I can apply the equal and opposite force equal to its weight at the centroid of this object and unable to balance it. So whenever you have a distributed load, for the purpose of analysis, we assume that that load is focused at the centroid or the center of gravity of that beam. Which means, as an example, if you have so distributed load and say maybe 100 Newton, and this length is 5, then this total load will be distributed at 100. So it will be located at 2.5. You agree with me? Similarly, it's not clearly stated in this problem, but what this is telling us is that these masses, center of masses, are nothing but the centroids of those respective segments. Means if this is the beam or that is the segment, its load is focused at the midpoint or the centroid of that segment. So if you look at the problem, it says G1. G1 is located at BD. BD is, so you have 1,500 kilograms. Then you have 0.5 milligram, 500 kilogram BC. So 500 kilogram here. And what you have is you have a concentrated load of 6,000 kilograms is located here. Are you with me? I want you to read this problem first, because it's a long problem. You have this tower crane, and typically that is how the tower cranes are built. If you go to the Tempe, you will see these cranes used for construction. There is always a counterweight at the end. The reason you have counterweight is to balance the moment. So you have a counterweight which is 6 tons. The mass of the boom CB is half a ton, which is 500 kilograms, and the mass of the boom BD is about 1,500 kilograms, which is 1.5 tons. And together, this crane is lifted 2,000 kilograms. Everyone understood this? That is how the problem setup is. Everyone understood why I have drawn forces going in the downward direction. Because that's the weight. Weight is in the action of the direction of gravity is going to act downwards. So that's why all the forces are going down. Everyone understood this? Now we have to find out moment about A and moment about B. I want to find out moment about A and moment about B. Now, this would be an excellent example where what I want to show you. I'm going to draw this here. This is 6,000. This is the lever arm. This is 500. This is 1,500. So this distance is 4. This distance is 7.5. This distance is 9.5 and this distance is 12.5. And this is point B. Now, it's always a good idea to add the coordinate system where you are taking the moments. Now, just for the kicks, can someone tell me what would be the force or forces at point B? Again, what is the God equation for statics? Summation of forces is equal to 0. Summation of movement is equal to 0. If summation of forces is not equal to 0, summation of moments is not equal to 0, that's a dynamics problem, not a statics problem. So do you agree with me? For this boom to stay where it is, all the downward forces should cancel out the reaction force. Which means the reaction force is going to be summation. Can someone tell me quickly? Summation of forces in y direction is equal to 0. So minus 6,000, minus 500, minus 1,500, minus 2,000, and don't forget the reaction force RB or YB. I'm going to call this RY. And that gives you the reaction. Do you agree with me? Now, if I want to find out the moment, I need to take the summation of moment about point B, and that's gonna be 6,000 times 7.5, positive or negative, 500 times 4, 1,500 times 9.5, 2,000 times 12.5. Do you agree with me? That is going to be your moment. Everyone understood me? Now, if I want to go forward with the boom thing, I do the exact same thing, but take moments about point A. I do the exact same thing, but take moments about point A. And it would be the same. This problem is exactly similar to the problem that I have solved. So this is going to give me a homework problem. 321. Okay, this is an interesting problem. Okay. So A, what this is saying is A dot P cross C is equal to A cross B dot C. Now, what you have is, and if you look at the solution, they have given a very long, convoluted mathematical solution. Okay. But I don't want you to follow that mathematical solution. I want you to tell me what it means, because I have already taught you this. So this is your A, this is your B, and this is your C. This is your A, your B, your C. All of them are unit vectors. All of them are unit vectors. And to make it, actually, you know this. Tell me, if everything is a unit vector, what is B cross C? You agree with me? B cross C is A. Okay. Now let me write this in a different fashion and everything will make sense. I dot J cross K is equal to I cross J dot K. What is J cross K? Remember circle of vectors. I, J, K. What is J cross K? I. You agree with me? What is I dot I? 0. What is I cross J? K. What is K dot K? 0. I need to prove. Understood? Okay. I'm gonna give this problem as homework. And I don't want a mathematical expression. Can come up with a mathematical expression in vector calculus. That's totally fine. I want you to understand what this expression means in terms of vectors. So just read A is equal to I, A is equal to I, B is equal to J, and C is equal to K. A is equal to I, B is equal to J, and C is equal to K, and work this problem out. Okay. Okay, remember the equation that I spent significant amount of time, R cross F is equal to moment, where moment is the cross product of vector R, which is the distance, and the force. Both of them needs to be expressed in the same and consistent coordinate system. Now, in this particular case, I want you to note, whenever you get a coordinate system that is not like the conventional coordinate system, always make sure that this coordinate system that is given to you is the right hand coordinate system. So X, then what you have is Y, and you have Z. You agree with me? So the coordinate system that is shown for this problem is a right hand coordinate system. So you will understand this word of caution. If the problem is defined in a left hand coordinate system, ignore that coordinate system and define your own coordinate system. Otherwise, the problem will go wrong. If the coordinate system is not right hand coordinate system, then assign a right hand coordinate system and solve the problem. But the good news here is the coordinate system which is given to us is a right hand coordinate system. So I'm going to assign the unit vectors. You agree with me? Unit vector in x direction is I, unit vector in y direction is j, and unit vector in z direction is k. You agree with me? Now, please note, they are asking end of the beam. So they are asking what is the moment given by this force. This force magnitude is 400 I minus 100 J minus 700 K. Can someone tell me what does this mean? This force is given as 400 I minus 100 J and minus 700 K. What is this? So what it's saying that this total force F has a component in x direction, which is 400 units. This force F that has a component in y direction, which is minus 100 units. It means it is going opposite the y direction. And this force has a component of 700 in the minus z direction. Everyone understood this? They have not given us the total magnitude of the force, but they have given us the values of the component of the force. You agree with me? Now, if I want to find out, if I want to ask you this question, with O as your origin, this is 0, 0, 0. Can you tell me for point B, what is its x coordinate? Can you see that point B has 8 as its x coordinate? Its y coordinate is 2.25, but is it positive or negative? Positive. And what is the z coordinate? 1.5. You agree with me? So this is the location of point B. Do you agree? So if I were to write down, and it is extremely important, whenever you have this, your position vector, which means this guy, this is the value of r. Position vector should start where you are taking the moment, and it should end at the location of the force. The position vector should start here and end here. You agree with me? What it means is, how do I go from point O to point B? I can go from point O to point B if I travel 8 units in I direction, 0.25 units in J direction, and 1.5 units in K direction. You agree with me? I repeat it once more. Position vector tells you how far you have to travel from your reference frame. Your reference frame is at point O. If you want to go from point O to point B, you need to travel 8 feet in x direction, in 8r. Then 0.25 feet in y direction, which is 0.25 j, and 1.5 in k. You agree with me? So my position vector, which is r, is going to be 8i plus 0.25 j plus 1.5 k. You agree with me? Now the fun begins. Why fun begins? Because now you have to multiply 8i plus 0.25 j plus 1.5 k cross 400i minus 100j minus 700k. You agree with me? Okay. Just remember, I cross I is equal to j cross j is equal to k cross k. What is it? Don't forget the circle of vectors. I, j, k. Okay. Can I take shortcuts? Everyone just pay attention on the board. 8 times 400, I cross I. You agree with me? 0. 0.25 times 400. So you have 0.25 times 400 J cross I. 0.25 minus 100 J cross J 0. 0.25 minus 700. So J cross K. So I'll write this on J cross K. Now what I have is minus 800. So 8 times minus 100 I cross J. Then 8 cross, so 0.25 times minus 100 that we did. You need to expand this. So how did I do? 400. So J cross I, J cross J is 0. J cross K. K cross D. And last but not least, so you have 708 times 700 minus sign I cross K, then 0.25 J cross K, and K cross K is 0. So now what you have to do is, final answer is going to be 0.25 times 400, which is 100. J cross I is minus K. 0.25 minus 100 minus, so this becomes 0. 0.25 700, so which is 125. No, 175. 175. J cross K is I minus 800. I cross J is K. K cross J is minus I minus 150. I minus I gets cancelled, and then you get minus 560. I cross K is minus J, and minus 175. J cross K is I. So you have to collect all the I's and all the J's. Everyone understood this? The other way to carry out this cross product, and I don't know if you have studied the linear algebra or determinant, is there is a technique which is called as the determinant. So you are going to have I, J, K. This row is R. This row is F. Now check this out. R is 8, 0.25, 1.5. Force is 400 minus 100 minus 700. And if you look at the solution that is given to you, they use this determinant method. So I minus 700 0.25 minus 8 times 400, and this is the determinant, minus j 8 times minus 700 minus 400 times 1.5 and plus k, which is 8 times minus 10 minus 400 0.25. This minus is a minus. So this is the matrix. Remember the movie The Matrix? So this is the matrix. This multiplied by this term minus this term. This term minus this term. So I minus 700 minus, I made a mistake. This would be 10 minus 1 point. I think this is not right. So 8, this guy is 0.25 minus 700. So I, and you do a cross product here, j, then you do a cross product here, and k, and then you do the 8 times minus 10, 400 minus 0.2. So this is called as the determinant of matrix. And you can remember this procedure. So I'm going to give you this matrix. You have A, B, C, D, E, F, G, H, I. This is your matrix, say M. And you want to find out the determinant of M. Please remember, determinant of M is A in the parentheses, E, I minus F, H. A that comes here, E times I minus H times F. You agree with me? Then the second term is minus B. Now you have D times I minus G F plus C DH minus G. And I will explain this once again. Please understand, if you want to find out the cross product of two vectors which are represented in a triad fashion, you can actually write them either in the matrix form and solve them, or can go to the cross multiplication, whatever is easier. If you use this determinant, your R needs to come here, your S needs to come here, and R cross S, or the determinant of N, is A ER minus FH minus B I DI GS and plus C, which is DH minus EG. Everyone understood this? Or you are welcome to follow the process that we did here. Okay, next problem. Exact similar problem. I'm going to give you as a homework. And I want you to solve this problem using two methods. Solve this problem using circle of vectors I, j, k, and solve this using the determinant I, j, k, Rx, Ry, Rz, Fx, Fy, Fc, and M is equal to R cross. Everyone understood this? It is extremely important for you to be comfortable with the cross product, dot product, and finding moments using these techniques. Okay. Now this problem should be a piece of cake for you. Determine the moment of the force F about point O. Determine the moment about force F about point O. Now, as you can see, this coordinate system is X, Y, and Z. Is this the right-hand coordinate system? If it's the right-hand coordinate system, I'm going to write this as I, J, K. This is right-hand coordinate system, I, J, and K. Now, I need to find out the position vector, this guy. So, OA. OA position vector means starting from O, going towards A. Starting from O, going towards A. So, can you tell me what are the coordinates of point A? To go to point A, how much do I need to travel in X direction? I need to travel 1 unit in X direction. How much in Y direction? -2, right? And to in the Z direction, 6. So do you agree with me? OA is equal to 1I minus 2J plus 6K. And you would do R cross F. And R is 1I minus 2J plus 6K. Cross. The value of F is minus 6I plus 4J plus 8K. You agree with me? Okay. Now I'm going to solve this problem one way. So the first part is 1I. You agree with me? Crossed with minus 6I plus 4J plus 8K. Minus 2J crossed. Cross. Cross. Minus 6I plus 4J plus 8K plus 6K minus 6I plus 4J plus 8K. You agree with me? Okay. I cross I. So in the last problem, I took a shortcut, but this problem I just want to expand and solve. I cross I is 0. 4 times 1 is 4. I cross J, K. 8 times 1, 8. I cross K, negative G. Minus 2 times 6 is plus 12. J cross I, negative K. J cross J, minus 2 plus 8, which is minus 16. J cross K, 6 times 6, which is minus 36. K cross I, K cross J, K cross K. So what do I get here? I get 4K minus 8J minus 12K minus 16I minus minus plus 36J minus 24I. You agree with me? Collect all the I's. 16 plus 24 minus 40I. 8 minus 8 plus 36. And 4K. You agree with me? He said, oh, 12 minus 8. Okay, yeah, minus 8. Yeah, I forgot this key. Minus 8. There is 1K here and 1K here. Okay. If you want to solve this with a cross product, same logic. I, J, K, 1, minus 2, 6, minus 6, 4, do you agree with me? I will let you work out the math. Can you do it? Or should I just write this down? I'll write this down. I minus 2 plus 8 minus 16 minus 24. You agree with me? This is a minus 40I. Minus J 8 plus 36. Oh, 8. And did I make a mistake somewhere? And plus K is 4 minus 12. So this is minus 8K. And just please check if if I did this math correctly. 8 I times J 6 4 I times K. Is it plus or minus? Minus 6 4 8. So please check my math. Probably I made a mistake somewhere here. So I get two answer correct. For some reason, my J answer is not matching. Can someone tell me the mistake real quick? Yeah. So this becomes Negative, no, what? Okay, minus, thank you. 36 and 8, which is 44. Thank you. Okay, finally, both the answers are correct. You see, both the answers are matching. And then mistake in that 36. So, everyone understood that should be minus 8, minus 36, because that j is not minus, that j is 31. Okay. Next problem. Similar homework. 328. You know what? I feel like teaching you, so no quiz today. So again, it's the same problem here, that you have a force. Now, in this particular case, what you have is they have not given the position vector, they have not given the direction vector for force. Now, if you want to solve this problem, you can solve this problem in multiple ways. You can resolve the force about x, about y, about z, and take the moment. Or what you can do is, you can represent this force as a force in vector. Now, do you agree with me? Right now, what it says that the force of F of 20 Newton, that tells you the magnitude of the force. It does not tell you about the direction of the force. You agree with me? Then we have to find out the moment of this force at the base of the pole O. So I need to find out the position vector OB. So what I need to do is, I need to find out the position vector OB. And somehow I need to find out this vector F. How can I represent the force of magnitude 20 newtons as a vector? This is the ijk, but do I know ijk's? How do I find out i's, j's, and k's? So here is what I'm going to do. And please remember this. You want to find out the unit vector in the direction of force. You agree with me? You want to find out the unit vector in the direction of force. This unit vector has the magnitude of 1, but it tells you what is the orientation of that force with respect to x-axis, with respect to y-axis, and with respect to z-axis. You agree with me? How do I find that out? So for that, I'm going to start something like this. So take this coordinate system, and for the time being, just for the sake of discussion, move this coordinate system over here. And there are multiple ways of doing this. I'm just going to show you one technique. This coordinate system, draw the coordinate system is j, k, and this is I. So you have j, k, and I. Now, if I want to go from point A to point B, if I want to go from point A to point B, I'm going to assume point A as my reference point. And why am I doing this? Because I need to find out the direction cosines, or I need to find out the unit vector. So I'm going to assume my point A is at 0, 0, 0. If I want to go from point A to point B, if I want to go from point A to point B, you agree with me, I need to travel 4 units in x direction. Do you agree with me? I need to travel 4 units in x direction. I need to travel minus 3 units in j direction. You agree with me? Minus 3 units in j direction. And I need to travel how much in k? Please note, the vertical height of the pole is 10.5. The location of B is 1.5 above point O. So that is 8.5. Do you agree with me? So it is minus 8.5. 10.5 minus 1 point minus 9. Correct. Sorry, minus 9. 90. So this simply tells me that my vector OB, which means starting from O going towards B, is given as 4i minus 3j minus 9k. You agree with me? So this is 4i minus 3j minus 9k. But it is extremely important to know this is the position vector. This is not the force vector. Everyone agrees? But yeah. But shouldn't it be AB because it gives the reference so well? Oh yeah, AB. Right. Thank you. This is starting from O. So this is the start point. Start. This is end. So this is the position vector. So this tells me the position. However, for my force to be represented along with this position vector, I need to find the unit vector n. What would be my unit vector n? My unit vector n is force divided by magnitude of force. Do you agree with me? And my force has the same unit vector. Divided by square root of 4 square plus 3 square plus 9 square. Do you agree with me? So this unit vector is not giving me the magnitude of the position. It's only telling me that my unit vector, my orientation is along the A to B orientation is given by n hat. Do you agree with me? So my force, if I want to represent this vectorically, this will be magnitude of F n hat. What is magnitude of F? 20. And what is n hat? Is this guy. 4i divided by this, whatever the answer is, 16 plus 9 plus 81, which is what? Square root of 106 minus Tj minus 9k. And then what you have is you have R. Now for R, you would again, since you are finding O to B, note with respect to O, point B is 4 units in I direction, then minus 3 units in J direction, and 1.5 units in K direction. You agree with me? And to find out the moment, you do R cross F. Now this is a very important problem. So you may expect to see problems like this in your next quiz, wherein I would give you the positions, locations of the forces. You have to find out the position vectors. You have to find out the unit vectors. So a very important problem. Please work out this problem as homework. This problem as homework. 336 and 337. And I'm gonna stop here.